This is Physics Lab 3, which looks at the magnetic field of a bar magnet. The purpose of this lab is to determine the magnetic field at differing locations around a bar magnet, and then to model that magnetic field in GlowScript. So the main physics concepts that are used in this lab are magnetic fields and Earth's magnetic field. And the general results were that the magnetic dipole moment was found to be 3.669 joules, and the net magnetic field observed from a 45-degree angle was 8.69 times 10 to the negative 5 newtons per coulomb, with the model predicting 7.5966 e to the negative 3 newtons per coulomb. So the magnetic field is a field produced by moving charges, which are currents, single charges, or magnetic objects. For bar magnets, this magnetic field is equal to some constant multiplied by r to the nth power. Now this constant is mu naught over 4 pi multiplied by the dipole moment of the magnet, which is then multiplied by r, and n is known to be negative 3 or 1 over r to the third. Now Earth also has a magnetic field, and this points from south to north and affects the net magnetic field at other locations. For the experiment, I first used a magnetic field app to orient the experiment towards the North Pole to avoid any interference from the Earth's magnetic field. Then I determined the location of the magnet chip in the phone by moving the phone around and finding out where the field was the strongest relative to the magnet. Then I moved the phone horizontally until the X field was equal to 20 microtorque and recorded the distance. I repeated that for 70, 120, 170, and 220 microtorque. Finally, I moved the phone to an equal X and Y distance away from the magnet, so at a 45-degree angle, and I measured the magnetic field at that location. So the distance and magnetic field results from the on-axis magnetic field experiment are shown below, and in order to linearize these results, I took the natural log of the x component and the natural log of the distance, and this yielded an equation y equals negative 2.85x minus 14.125. Now in this case, the slope can be considered to be the exponent that r is given, so the n of r to the n, and the y-intercept can be considered to be the natural log of k. And this natural log can be used to solve for k, and as we know, k is a constant that is composed of mu naught over 4 pi multiplied by 2 times the dipole moment of the magnet. So all those values are known except for the dipole moment, so u can be solved for, which in this case was 3.669 joules. And then the n component of r to the n was negative 2.85, which is approximately negative 3, which is expected. The off-axis magnetic field was found to be 8.69 times 10 to the negative 5 teslas. So as you can see below, I created a model to find the magnetic field of a dipole. So using the magnitude and the direction vector for the position vector, and then a function for the magnetic field, which you can see on the fourth line. B is equal to 3 times the dot product of mu and r hat in the direction of r hat minus mu. And then this is multiplied by mu naught over 4 pi divided by the magnitude of r to the third. And so using this, I was able to find the magnetic field at 45 degrees, so at a distance equally in the x and y direction. And as you can see below, the magnitude of this vector was found to be 7.59664 times 10 to the negative third. So using those magnetic field values from the last slide, I was able to create arrows at certain locations that show the direction and the magnitude of the magnetic field. So as you see, the orange arrows represent the magnetic field in areas parallel to the position of the magnet. The blue arrows show the magnetic field in positions perpendicular to the magnet, so at a 90-degree angle. And the one magenta arrow shows the magnetic field at that off-axis 45-degree location from the magnet. So if the phone wasn't oriented completely north to compensate for Earth's field, then the measured field components and the net field could be higher or lower than that which was actually created by just the magnet, because Earth's magnetic field is also pulling on that magnet chip in the phone. Now, if 2 magnets were used as the source magnet instead of 1, the magnetic field from the magnets would be stronger. The field, however, would not be doubled because the center of the 2 magnets would be further from the yardstick than a single magnet because it's double the length. So the field would be slightly less than double at the previous locations.